what are some examples of things that satisfy the axioms of probability? Perhaps the simplest example of a probability distribution is the uniform probability distribution. And what it does is it basically says if I have an outcome space S, let's say that S is the numbers 1, 2, 3 on up to n, then the probability of any subset of S is equal to the number of elements that are in that subset. So this hash mark is pronounced cardinality. And what it's defined to be is the number of elements in a set. So the cardinality of a set A is the number of elements in a set A, if A is finite. If you have transfinite numbers, then cardinality gets more complicated. You have things like aleph null and the power of the continuum and things like that. We're not going to worry about that. OK, so this hash mark means the number of elements in the set. And the uniform probability distribution on a finite set is defined so that the probability of any subset of the outcome space is equal to the number of elements in the outcome space divided by the total number of elements in the set. So the chance of a set A is the number of elements in A divided by the total number of elements there are in S. Okay? So an example, so first let's verify that this satisfies the axioms, that you really can call it a probability. So in order to be able to call it a probability, it has to satisfy those three axioms. First of all, is it possible that this P defined this way could assign a negative number to some subset? The answer is no, because no set has a negative number of elements. And so the number of elements in a set is always at least 0. So the probability of a subset is always at least 0 divided by n, which is 0. So you can never get a negative probability if this is how you define probability. What's the second axiom? It's that the chance of S, the probability of S, has to be 100%. So if we define probability this way, the uniform probability, what is the chance of S? Well, it's the number of elements in S divided by the number of elements in S, which is 100%. So it satisfies the second axiom. What about the third axiom? Well, that says that if A and B are disjoint, then the chance of A or B has to be the chance of A plus the chance of B. Well, if A and B are disjoint, the number of elements in the union of A and B is the number of elements in A plus the number of elements in B. They don't have any elements in common, right? So since the number of elements in the union is the number in A plus the number in B, then the chance of the union is the number of elements in the union divided by total number of things there are. That's the number in A plus the number in B divided by that. That's the number in A divided by that plus the number in B divided by that, right? So it works out. So this is an example of something that satisfies the axioms of probability. It can be called a probability. And it's probably the simplest thing. We're going to use the uniform probability distribution really often to model things like dice rolls, coin tosses, shuffling a deck of cards. If we're talking about a well-shuffled deck of cards, what are we talking about a uniform distribution on? What would have the uniform distribution? Let's back up. We're talking about rolling one die, one fair die. What would we represent as having a uniform distribution? We're rolling a die, and the thing we're interested in is how many spots are showing on the top face of the die. I feel all alone up here. OK, so what are the possible outcomes if I roll a die? What are the possible outcomes for the number of spots that show on the top face? 1 through 6. And so uniform probability distribution would say that the chance that I roll a 1, for the sake of argument, is equal to the number of elements of the set 1 divided by the, so what's the total set of things that could possibly happen? What's the outcome space for the number of spots that show on top of a die when you roll a die? Okay, so the outcome space S looks like 1, 2, 3, 4, 5, 6, right? Those are the things that could possibly happen, the numbers that could possibly show on the top face, okay? And so what's the uniform distribution on this? Okay, so what is a probability going to do? It's going to assign numbers to subsets, right? In such a way that the chance of a subset is equal to the number of elements in the subset divided by the total number of elements. So what's the total number of elements in S is equal to what? 6. Okay, so the uniform probability distribution says that the probability of a set A is equal to the number of elements in A divided by 6. So in particular, it would say that the probability that I get a 1 on the top face is equal to the number of elements in the set 1 divided by 6, which is 1/6, right? What's the probability that I roll an even number? Okay, so what outcome corresponds to rolling an even number? Okay, so 2, 4, 6. That's the event that I roll an even number, right? So the probability of 2, 4, 6 is equal to the number of elements in that set divided by 6, which is 3/6. Right? Okay, so this is what we're talking about. Okay, the uniform distribution in this case says the probability of a particular event is the number, is the cardinality of that event, the number of outcomes there are in that event, divided by the cardinality of the whole outcome space.